Welcome back to another episode of Insects for Fun. Today, we're descending into the dark, damp, and mysterious underworld of deep cave systems to explore some of the weirdest insects that you've probably never heard of. These are creatures that live out their entire lives in total darkness. No sunlight, no seasons, just rock, water, and whatever organic debris trickles in from the surface. And some of these insects are so uniquely adapted to their specific caves, they can't survive anywhere else. Let's start today's episode by asking what exactly makes a cave-dwelling insect different. First off, cave-dwelling insects are usually classified as troglobites, true cave dwellers. Troglophiles, species that can live both in and out of caves, and troglocenes, species that use caves occasionally, but don't live there full-time. Troglobites are the real stars here and often have distinct features like reduced or completely absent eyes, lack of pigmentation, elongated appendages, and slower metabolism and longer lifespans. They also tend to be incredibly specialized and sensitive to environmental change, which is why many of them are endemic to just one cave or one cave system. We're now going to look at different species across different families of cave-dwelling insects, starting with the first cave insect ever described, Leptodyrus pochinwartai. The family for this species is Leodidae, and it's endemic to the Dinaric Alps in the Balkans. It was first described in 1831, and it's a classic example of a troglobitic beetle, completely blind and heavily adapted to cave life. It has an enlarged abdomen, fused elytra, and antennae adapted for navigating in complete darkness. Honestly, this beetle looks pretty cool, and you should definitely check it out on the Instagram or Facebook if you get the chance. The body looks like a golden bead or a solidified bead of honey attached to a thin thorax. In fact, its scientific name is actually in reference to the thin thorax, with leptos meaning thin and dyrus meaning neck. It doesn't just look cool though. This beetle's body serves a purpose, and it is to navigate and survive in extremely dark caves where the temperatures don't go above 12 C or 54 Fahrenheit. The elytra are fused to trap water in case the environment becomes incredibly dry. And its antennae even have special organs that determine the humidity. Leptodyrus feeds on decaying organic matter, fungi, and occasionally carcasses of other cave organisms. It plays a key role in the nutrient cycling. It also produces really slow, and it only has one larval instar. What's even more wild is that the larvae don't feed before molting, which begs the question, why even have a larval stage? Unfortunately, very little is actually known about these insects, and we aren't even sure about their populations. But it is inferred that they're probably vulnerable and have been added to the red list in Slovenia. We also know that there are 6 other subspecies found within the cave systems of the Dinaric Alps. Next up, we've got a rare earwig known as Ericksenia esau. This wingless, blind, and pale earwig is found in cave systems of Southeast Asia, particularly in Borneo, and it was originally thought to be a parasite on bats. This has since been changed though, because the earwigs cause no harm to the bats at all, and if anything, are a free cleaning service. Ericksenia esau lives on the bodies of hairless cave-dwelling bats, specifically Carameles torquatus, feeding on glandular secretions and dead skin. The female gives birth to incredibly small live young, and these tiny nymphs cling to the mother's body until they're mature enough to seek out bats on their own. It's kind of ironic because the host for this species is hairless, but the insects themselves are commonly referred to as hairy earwigs because their bodies are covered in short sensory hairs known as setae or setae depending on who you talk to. But we're going to leave these hairy Borneo earwigs now and travel to South America, where we can find a very strange bark lice found in the dry cave systems of Brazil. Bark lice have not been formally introduced yet, so I'll give you a real quick introduction. Bark lice belong to their own order of insects known as Cicodia, with a silent P. They are not the lice associated with humans and are not parasitic. These small lice-like insects feed on plant matter such as lichens, algae, fungi, and even man-made starch-based glues seen in old book bindings. The genus we care about in today's episode is Neotrogla, from the family Prionoglarididae. These cave bark lice actually shocked the scientific world with a unique reproductive anatomy. Females have a penis-like gynosome that they use to extract sperm from males. This reversal is thought to be an adaptation to nutrient-scarce environments, where seminal fluid provides females with extra nutrition. This might actually be similar to the volcano cricket we mentioned in the last episode, where the female crickets feed on or eat a male's leg. Our final insect is actually the first cave-dwelling insect found to fly, and also one of the deepest insects ever found, Troglocladius hodgdii, family Chironomidae. This non-biting midge was discovered deep under the Velebit Mountains of Croatia, at a depth over 980 meters in the world's 14th deepest cave system, Lucina Jama. And no, I have no idea if I said that right. But what I do know is that this is one of the deepest habitats ever recorded for an insect. And these insects, as you'd expect, have adapted to life in total darkness, including a reduced metabolic rate and a tolerance to hypoxic conditions. Now, what on earth does hypoxic mean? It's a wacky way to say lack of oxygen. But what's really odd is that the adults have fully developed wings and are able to fly blind. Even stranger is that so far only females have been found. So what are they flying for or from? These insects feed on detritus and microbial mats within the cave pools, and adult emergence is rare and poorly understood. Actually, the scientific name hodgdii is in reference to underground fairies in Slavic folklore. And that is where we're going to end today's episode. I hope you guys enjoyed it, and as always, make sure to rate the podcast 5 stars wherever you listen. And leave a review if you can to really boost the visibility. Now, if you would like to support the show and check out an ever-expanding catalog of vlogs and bonus episodes, then Patreon is where to go. Thank you again for listening, and until next time, stay curious.